Hello everyone, this is Vipin Gopal for you to present the additive manufacturing topic, which is fused deposition modeling (FDM). So before going to the actual working of the FDM, let me take you through to an overview of rapid prototyping. Some of the current rapid prototyping technologies are liquid phase, are considered in liquid phase, powder form, sheet form, or gas phase. If we consider liquid phase, there are processes such as stereolithography, FDM, the topic which we are going to study, plastic particle manufacturing, multi-processing, model making. And in powder form, in liquid phase mainly, the material which we take is in liquid form, and the material which we take in a powder form is in powder form, and the mainly we use SLS method, 3D printing, and laser engineered net shaping in this powder form, and rest of them are sheet form and gas form. Introduction. The fused deposition modeling is an additive manufacturing technology. FDM is basically an additive manufacturing technology. The synonyms of the additive manufacturing technology are 3D printing, rapid prototyping, etc. So it is used. It is basically used for modeling, prototyping, and the production application. One of the technique, as discussed earlier, this technique is used for 3D printing. The additive FDM works in the principle of additive manufacturing, which depends upon the setting up of layer by layer manufacturing. So, what is? Let me take through the global scenario of an FDM. FDM was developed by Scott Drum and the founder, who is the founder of Statatis, and was commercialized in 1991. Statatis has got almost 60% of the market share in FDM in India. Almost 200 plus of FDM systems are installed in Indian market in various segments like education, industries, defense, government, aerospace, and automobile sector, etc. And in this, global Statatis has almost 45% of the market share. In the graph shown below, we can see that almost 31.7% is shared by the motor vehicle, and 18.4% is shared by the consumer product, and rest by the business, medical, academic, aerospace, and government. Now, what is an FDM process? How can we categorize an FDM process? The FDM process can be categorized into three distinct steps. The step one is pre-processing. In pre-processing, what we do is we model the required model in a modeling software such as CATIA, SolidWorks, etc. And we use this model, with the help of this model, we feed it in a feed it in FDM machine, which is by converting it into a STL format. Now, step 2, production. In step 2, what we do is we feed the model in an FDM or a rapid prototype machine, and what it do is it converts into by converting into the STL file, and what machine do is it creates a layer by layer section of the modeling. It slices the layer of the model. The first layer of model. The first layer of the physical model is created, and in this process it takes in almost three directions: X, Y, three mutually perpendicular direction, X, Y, and Z. The bed mainly moves in X, Y direction. After creating one layer, it can be a bottom-up process or a top-down process. After going through the top-down process or bottom-up process, we create a layer by layer modeling of the required model. The model is then lowered by the thickness of the next layer. After creating the layer, we have to move to the next layer. And this layer is created by lowering the. In this process, we create the layer by layer, and after creating the layer, we can move bed is moved to Z in Z direction for creating the next layer. In this process, the process is repeated until the completion of model is done. As we can see in the diagram or the figure, the tool path of the FDM, where it moves by layer, where it moves in a it can be moved in a linear way or in a zigzag way to complete the modeling. Keep slice XML files showing the sample with the bed width, air grab, and raster orientation. These are the orientation or specification of the of this file, in which we can see that see whether the breadth width is given, air gap is given, or the raster orientation variation is given. These are needed in order to establish the property of the STL file. Then step 3 is the post-processing. The model or any support are removed by washing or stripping it away, and the surface of the model is then finished and clean. While creating a model, it may have the hanging parts. In order to support this part, we need a support. If else we do not give a support, it will result in the sagging. So in order to avoid the sagging, we give the support material. This support material basically soluble in detergents, which can be removed by dissolving it into the detergents, or it can be chipped away by using a chisel. And the main thing we have to consider in this condition is that the material should main model should not be damaged. So the process should be done in such a way that while removing the support material, the surface of the model should not be damaged. Now, how FDM works? It is basically a 3D printer in which works on the FDM technology. Build the parts layer by layer by heating thermoplastic material to a semi-liquid state and extruded it according to the compute control. What it does is it takes a material, it can be in the wire form or in the pellet form. It is heated, this thermoplastic material is heated into a semi-liquid state, and it moves along the path according to the shape to be created, and it extrudes according to the computer controlled path. The FDM uses two types of material to execute the print job. The first one is modeling material, and the second one is support material. Modeling material is mainly decide upon the properties of the model to be required, and support material is used for supporting the model, as discussed earlier. Material filament fed from the 3D printer material base to the printer head. How it feeds? It consists of a nozzle through which the material is poured, and through the nozzle it moves to the required shape. Where the nozzle is moved to the required points, and the model is created. Mainly the material deposition is in XY direction, and after deposition the base moves to the Z direction in order to complete the model or to complete the next layer. After building, the user breaks the support material away and dissolves it in the detergent or water, and the part is ready to use. As I said, after creating the model, it is either dissolved into the detergents or chipped away with the help of a chisel in order to get the model part which can be used, which can be readily used. FDM technology, as shown in the figure, we can see here it consists of two material cartridges through which the filament is extruded, and it is liquefied, or we can say that the thermoplastic material is heated. In one side it consists of a support material, and another side it consists of modeling materials such as ABS, PS and PPSF. These both are liquefied and fed to the nozzle, and with the help of a nozzle and the computerized path, it moves through a path through which it has to be created and creates the model. Now, what are the advantages of the FDM? FDM is a clean process, simple to use, office-friendly 3D printing process. In what sense we can say that it's simple to use and office-friendly? Because it does not need any It does not need any skilled worker, and it's office friendly in the sense that it does not need a large space to get to be installed. It is same as our normal Xerox machine or a printing machine, and it can be installed in an office also, in a small space. Thermoplastic parts can extrude exposure to heat, chemical, humid or dry environment and mechanical stresses. The material which we create is basically sintered, and it can be exposed to a wide variety of conditions such as heat, chemical, humid or dry environment. It can also undergo mechanical stresses. Soluble support parts make it possible to produce complex geometries and cavities that would be difficult to build in the traditional manufacturing method. These soluble support materials, as I discussed, that support particles are soluble in detergents, we can use it to create the complex shapes or the intricate shapes which cannot be produced by using the conventional machining process. With the help of this, we can create the complex space, and the rest of the support part can be chipped away. This is a comparison between FDM and traditional manufacturing technique. If we consider conventional machining process, this is produced by removing the material by bit by bit. As we know that it is a subtractive process where we use the tool piece, tool to remove the workpiece layer by layer or bit by bit to create the required shape. As far as the complexity is concerned, it is limited as we cannot make intricate shapes in such kind of processes. Basically, the conventional machining processes. The example of conventional machining processes: CNC machining, rapid prototyping. It is produced by modeling material layer by layer. As I have discussed in this FDM process, the layers are created. The material model is created layer by layer. The layer by layer deposition of the material takes place. It is an additional process because we add a layer after layer as the modeling of one single layer is done. As far as complexity is concerned, the complexity is unlimited, and we can make the intricate shapes and unlimited complex objects. Disadvantages: the extrusion head must continue to move, or else the material bumps up. As I have discussed, that the nozzle, it consists of a nozzle head. It should be moved constantly through the through the layers in order to form a layer of uniform thickness, or else if the speed of the speed of the nozzle is slow or it is stopped, the material coming out of the nozzle tends to bumps up, creating an extra thickness of the layer. Support is required. As we have discussed, that it consists of overhanging parts. These overhanging parts need to be given a support, or else it will result in the sagging, as in a condition of a cantilever beam. The part strength is weaker perpendicular to the built axis. It is considered that the part strength of the material which we are making is weak in the perpendicular direction in the build-up axis. The layer increases. As the layer increases, the build-up time increases. It is obvious that if we increase the number of layers, the number of processing time is increased. The number of the time required to make each single layer increases. The temperature fluctuation during the production could lead to delamination. If we increase the temperature or decrease the temperature, the proper bonding will not happen. For a particular material to form a bonding process, it needs a particular temperature. If temperature fluctuation is there, it will cause in the debonding, and which will result in the delamination process. Delamination process is in which one layer will not merge with the another layer, and it will result in the model failure. Some of the applications of FDM are aerospace, For example, in aerospace, it is used for creating the human supporting rovers. In automotive parts, most of the automotive parts which are manufactured or forged are being replaced by the FDM method. By using the FDM method, we can create more complex parts. Commercially, the popularity of the FDM is increasing. For example, it is used for creating the mobile covers, bottles, any plastic models can be created very easily with the help of an FDM. In industries, it is used for make it mainly the die replications, in which we can make a die model in a FDM, and we can use it for replicating the material in casting. In medical, we use it for drug injection system. For example, it is the most recent topic in FDM, where we can use a capsule shaped model in which consists of a number of pores, and we can inject the drug material into any part by using this capsule, which consists of a number of pores, and it easily diffuses into the organ. This is all about my topic, FDM. Thank you.